session and to the world of digital transformation. Construct Next is AEC Industries 4.0. I'm Sunil Prabhakar, CEO at Bay Building Architecture and Engineering, based out of my Bangalore office. We are into the business of architecture, construction, interior fit out, and transformation consulting. Let's look at what is Construct Next, which is all about creation of intelligent building systems. We present here a strategy, design, and implementation for measurable digital transformation in AEC, what we do through our business vertical of transformation consulting. Bryden Wood, one of UK's famous architects, created an inventive factory in a box, which was an assembly kit for a pharmaceutical factory, a complex one, by creating a step by step assembly process. The firm reduced the size of the labor at the site by about 75% and the time consumed for the construction by about 50%. So, what we're trying to say is every company today has to think like a technology company and then look at the different verticals it seeks to disrupt. So, what is an intelligent building system and how can we apply that to a practical real case? This is what Next Lab at Bay explores in this particular presentation. An intelligent building system, by definition, is one that helps the construction companies save resources and increase productivity and improve the project profitability, quality, and reduce the project duration and cost, reduce the complexity of the project management, and enhance the overall site safety for promoting sustainable development. Next Lab at Bay looks at IBS or Intelligent Building System from a multi-pronged perspective. The first one is to create a strategic view based on a forecast digital-driven value chain transformation or disruption. The second is an operational view as to how to decompose the strategic view into a pattern that can be applied across verticals. A technology view in which case we assess the different technologies that are available and how the frameworks of technology and networking makes it possible for us to convert the operational view through the technology into an intelligent building system, and a transformation measurement view that lays the basis for an objective basis for measuring the transformation quotient. Let's see the different views. First, we take a look at the strategic view. Let's take a look at the value chain of a conventional or an evolved value chain pattern in our industry. From the raw materials to renovation to demolition, back to raw materials across manufacturing, design, engineering, construction, and operations. There are several stakeholders currently, new stakeholders coming into the mix through different types of innovation. So this is how an evolved value chain currently, as most of us know it, exists. Now, each link in this value chain that you've seen is set to undergo drastic reformation based on the digital disruptions. Let's take a look at the raw materials, the basic building blocks, which from a conventional cement, sand, aggregate, reinforcement, bricks, blocks, etc., goes through industrialization to become prefabricated RCC components like columns, beams, etc., prefabricated homes, bath pods, pre-engineered building systems, factory in a box, which you've already seen, and thereafter, through industrialization, industry 4 or digitalization, it becomes converted to smart construction objects and intelligent building systems and reformed materials or innovative materials like 3D printing solutions. So this is how the raw materials link in the value chain has transformed or will be transforming due to the digital disruption. And with almost all the verticals getting consumed by industry 4.0 or the digital revolution, it is sooner or later we'll have where we are headed. The value chain transformation in our industry would look something like this, where you can see the areas highlighted in red are the different technologies that are going to disrupt the different links in the value chain. And therefore, we are in the near future headed to some 4.0 location like this, where we have prefabrication, modular construction that will be rampant, advanced building materials, 3D printing, additive manufacturing, autonomous construction, augmented and virtual reality, big data, predictive analysis, wireless monitoring, cloud and real-time collaboration, 3D scanning and photogrammetry, and building information modeling. So these are some of the technologies which will drive the use cases for the digital transformation of Industry 4.0 in our industry. So Everything that you saw in the previous slide is a thing as defined in the Internet of Things. Let's take a look at the operational view based on a forecasted suite of use cases. IBS is a product of an end-to-end digital transformation initiative across a company's or an industry's standard operating process. A company often asks the question, what needs to be or can be digitally transformed? For example, a suite of activities in a typical post-contract repository would look like this across construction documentation or setup or procurement, construction management, inspection testing and protocol reviews, reports, etc. have got several activities or tasks associated in a post-contract ecosystem. Now, the IPS's operating view examines a suite of activities, which we've shown before, and identifies an aligned suite of technology and other solutions to aid the transformation of each activity or operation and establish a collective automated operational protocol for it. That is the operating view. As in a simple example, let's take a look at the combination of a suite of building information modeling and IoT, which creates a digital twin on a building information modeling platform. Next Live is a multi-sided platform, and we work with the aggregated digital expertise in the quest of a converged whole. Virtual Win is one of our associates in the realm of building information modeling. And let's take a look at how BIM is transforming the industry. It's not a disruption anymore because it's already existing, but with IoT, which is a serious disruption, BIM combines to create a digital twin and makes it possible for us to plan and schedule using the platform, create a baseline versus actual scenario in real-time monitoring of the project. Um, um, it creates a cost estimation analysis, asset management schedule with its 5D capabilities. The sixth dimension of the BIM makes it possible for us to create energy analytics to uh, aid sustainable energy consumption. And 7D, which is probably one of the most important aspects of BIM in terms of being able to contribute to the operational and facility management well-being of the structure after the construction is over, by having a complete set of data straight away retrieved from the construction site as and when it happens through IoT technology, through sensors, transmitting the data back to the BIM platform in the studio and creating a virtual or a digital twin in the process. So it also helps us in achieving the function of clash coordination between the services, which is a very, very important part in ensuring easy project management and construction supervision. Further, we also do research with specific trends that are that are occurring all over the world and specifically to our country, and identify practical use cases across the technology spectrum. In IBS, it's required that we engage in a suite of digital technologies. Based on those technology, we collect data which we acquire, store, visualize, and analyze to create a rationale for engineering outputs of products, which is the ultimate intent or the objective of using the digital technology for the betterment of our industry. So let's take a look at this combination of technologies that are available and the different use cases with which it integrates over a network to create rampant changes or disruptions. The rate of change is far removed from what used to happen in the past. It's not linear anymore, it's exponential. So a mix or a complex web of use cases and technologies are shown here, which means that the investors are looking to make investments in the technologies such as ERPs and other serious digital disruptors, particularly predictive analytics and big data, IoT, and drones. And particularly, and as far as India is concerned, given its special nature of the challenges, the software investments are currently hinging around ERPs and project management and scheduling softwares. However, the time is not very far when we combine all the other technologies also to create platforms uh, which will be a converged whole platform using a combination of technologies to deliver optimum quality outputs or deliverables to the industry. Let's take a look at the technology view, how this technology is employed in different frameworks. There are three different frameworks that we are creating, which I'll talk to you in a bit. Firstly, we develop a conceptual framework of the intelligent building system. Then we analyze the operating mechanism of the IBS. Then we look at the implementation part of the IBS. In all of this, we take a technology view and not the strategic or the operational view of the platform itself. So First, looking at the stakeholders, we have the owners, the regulators, designers, constructors and contractors, engineers, component manufacturers, and logistics carriers, each with a specific set of responsibilities and each within a particular zone of experiencing the changes due to the transformation. So, what digital technologies are to be employed? To understand this better, we have to divide the prefabricated building, which is the use case that we are taking. We have to divide that in three different levels: a unit level, assembly level, and the integration level, which is a component level or the construction system level and the construction site level, respectively. In the prefabricated component level, we identify, locate, and track prefabricated components through the connectivity of the IoT to realize visualization and traceability of the component information. In the system level, or the construction system level, again in the factory environment, we plan and optimize the construction process through real-time collection and integration and interaction of the construction production process. And at the site level, where the components and the construction systems are assembled, we realize intelligent management, control, and optimization of the construction process for smart construction. At the level of the components, we use IoT, RFID, and GPS to achieve our objectives. At the construction system level, you use a combination of IoT and a BIM platform to interchange and transact the data and information. And at a construction site level, we use the technologies of internet, 3D scanning, BIM, virtual reality, augmented reality, and IoT, AR, VR, etc. And to propose a BIM-based field management model that can intelligently manage information related to HR, resource allocation, QA, QC, site supervision, health and safety, etc., etc. So we've seen these are the different technologies like IoT, GPS, RFID, BIM platform, internet, 3D scanning, etc. These are at the core of a prefab digitalization. We will look at the three frameworks that we talked about. For looking at the framework in detail, as data is king in almost all things digital, we have to create different sources or blocks of data, which will then over a network flow information across to and from, and be responsible for creating the interpretation and thereafter creating of the product that we're after. So there are four primary blocks when it comes to a prefabricated building. You have a block PIC, which is a project level information block, IBDB, which is the IoT BIM-based database block. Then we have an AMTS, which is the authority regulatory block. And we have an ISP, which is a system for the construction of digital engineering products, which is a combination of all the, which takes cognizance of all the data and information, analyzes, acquires, interprets, visualizes, and creates the products that we are after. So to sum up, the big data acquisition is the function of these four blocks: PIC, IBDB, AMTS, and ISP. A project level information center, IoT-based, BIM-based database, authority monitoring and traceability system, and information system for products. This also integrates further with several systems and subsystems of the manufacturers, the designers, the contractors, logistics operators, etc., etc. So each of these contractors, if you want to call them that, would have their own system, subsystems, like the project quality traceability system of a manufacturer, or a construction site resource element management system of a contractor, or a component production planning scheduling system in the prefabricating factory, or a component transportation and a dispatch system, CTDS, of a logistics operator, or an integrated design system, IDS, of a design consultant. So with all these different blocks of data, combining with the blocks of data of the manufacturers and their subsystems, we create a conceptual view where we highlight the main objectives of the authorities, the contractors, and the owners, which are supervision and control, lean construction, maximizing benefits, quality traceability, etc., how they combine with the subsystems of the manufacturers, etc., interact, transact information between those systems and subsystems, and through the network of RFIDs and Wi-Fi's and Bluetooth and what have you, interacts with the construction site to deliver a solution across resources, components, equipment, systems, men, and things. So this is a conceptual framework which leads us to an IBS technology view operating framework. In this particular slide, you can see three different distinct frameworks. One is a design framework that is highlighted in a dotted red lines, and the other is the component production or the manufacturing framework, and then you also can see the on-site construction framework. So what happens is, in the through design and design process, where you create a design model, analyze it, and once it clears the clash detection, data that is construction oriented is transferred onto the on-site construction. Data that is manufacturing oriented is sent across to the manufacturing facility, and this data is then checked, analyzed for quality in terms of clash clearance and design conflicts, etc. It's only upon the clearance of, because the data keeps interacting with each other at the construction site, at the manufacturing facility, and at the component level, at the system level, etc. When it comes to the construction site, then any errors or any mismatch between what has been created and what needs to be implemented at the site is recorded, and if there is a design conflict, it's sent back to the design, back in the loop to create a new design model, and then the final refined component construction system and the construction site is thereafter created and finished. So this is the technology view, the operating framework of the technology view. And how do we implement this concept and the operating framework? It is done through a simple 10-step process where we build the smart construction objects. As we've seen earlier, the construction objects that are created from the prefabricated components, we build them first, establish a data acquisition system. We've seen that, collect data from SCOs through the data acquisition system, establish a network integration system, connect these SCOs through the integration system, establish an information integration system. The data information is created from the data, transmit the collected data to the information integration system, and establish a data and integration and analysis system, analyze through visual integration system, and establish a multi-layered application integration system, which results in creation of your application of the product through the ISP. So that's what now we've seen the technology view, we've taken the operating view earlier, and we have taken a look at the strategic overall wide canvas view, which brings us to the transformation measurement view for IBS. Now, we have used information and researches from various big five consultancies like BCG, McKinsey Global, and we're inspired by the balanced scorecard approach to strategy implementation by Kaplan and Norton. And although we are at a work in progress for creating the digital transformation value chain transformation scorecard, what BCG has set out as a paradigm requirement for creating this digital transformation is an integrated strategy with a clear transformation goal, leadership committed to the goals, deploying high caliber talent, agile governance system, effective monitoring by lining out milestones, and a business-led modular technology. This is one of the approaches of BCG. Similarly, we look at other consultants, big five consultants as well, and we can see how we go about creating a value chain transformation scorecard, which is the implementation measurement of the IBS strategy for a prefabricated building. The same can be done across different types of buildings. So what are the different 10 platforms? We look at a prefab modular construction platform, advanced materials platform, design digitalization platform, BIM platform, autonomous construction platform, big data platform, wireless monitoring platform, cloud and real-time collaboration platform, 3D scanning, and a blockchain platform. At Next Lab, where we are a multi-sided, we are an MSP, a multi-sided platform where we bring all the digital talents together. We have established for the value chain transformation clear KPIs and objectives across the different value functions in a company or a vertical, and then identify the different measures, which are the lag measures or the outcome measures, and the performance drivers, which are necessary to create the digital transformation in a company across these different platforms, and those can be measured for the efficacy of the implementation. So a few of the scorecard templates we can show here. We have not gone into the details of the outcome measures and the performance measures and the actual status, etc., because these are all specific to the nuances of the way the company operates in. So if you see in the prefab or modular construction platform, you have clearly mentioned objectives which lead to the KPIs, which is a product optimization, quality control. So all these measures that are created here will be a function of these objectives and the use cases that we had mentioned earlier about. By defining the different use cases across the different departments in the company, in a post-contract environment, you've got the construction management part, or the setting up part, or the mobilization part, etc. So defining the key objectives, and I've given a description of some of these objectives also. Defining the measures here, and what needs to be the outcome measure, and to achieve that outcome measure, what needs to be a performance driver to ensure that we get product optimization by creating these systems, and most importantly using these technologies: IoT, RFID, GPS, BIM, IoT, RFID, GPS, etc., etc. So the different technologies that are necessary to be employed for us to implement these systems, by which we can make a paradigm change in the way that the companies and their different departments operate. So here is a scorecard, kind of a template of a scorecard for a prefab and modular construction platform. We've shown you digital design digitalization platform here. This is different from a BIM platform because BIM is a complete different area in itself. So this is some of the scorecards or some of the KPIs for the design digitalization and autonomous construction platform. Again, the technologies that are in play here also illustrated in this big data, predictive analysis platform, etc., etc. So the digital transformation, we are doing currently we're doing a project in South India, which is a 2 lakh square feet project for a German principal, and they manufacture generators for windmills. And the digital transformation approach, using this different views, that is the operating view, the strategic view, the operating view, the technology view, and this particular digital transformation measurement view is being implemented. It's a work in progress. And this is being done using a 10-step IBS framework and a 10 platform IBS strategy. So since the time is short, if there's any query that you want to inquire about, you can contact me on these email IDs and mobile number. And for the opportunity, thank you again. Thank you for your attention. And from all of us here at Next Lab, thank you so much.